Hi, my name is Dan Finkel. I am the founder of mathforlove.com, and here today to share a puzzle that I really like. This is really a magic trick, and I've always wanted to do this magic trick live, but I thought of it during the pandemic. I have not been able to do it in front of a live audience yet, and so I'm going to try it in front of you here for the math buffet here in this moment, and anyone who sees this video afterwards, for you too. And I hope it's going to work. And at the very least, I'm going to show you how I would have done it live. And you can imagine how cool it would have been. But let me start with something else. There's a classic puzzle that a lot of people have talked about. This is a puzzle that really awakened them to seeing how cool math was and to loving math. And it goes like this. And you can do this right now. You choose a 3-digit number. And you can write one down. The best way to do this is actually write it down, or type it into your computer, or keep a record of it somehow. You've got your 3-digit number. Everyone got it? Then you repeat it to create a 6-digit number. And then we're going to do some stuff to it, okay? So let's say I pick 291, for example. That's my 3-digit number. I will double it. I'll write it 2 times in a row. So it's now 291,291. This strange little 6-digit number. Fine. And now, I wonder if this number is divisible by 7. Now, picking a number like that, like saying, oh, what's the chance that this number is divisible by 7 evenly? In general, if you just have a random number, the chance that it's divisible by 7, some arbitrarily picked number, is about 1 in 7. Because every 7th number is divisible by 7, so there's 6 that aren't, then 1 that is. It's like if I woke up from a coma and I said, is today Monday? What's the odds? Well, it could be any day. They're all about equally likely. Monday's 1 of the 7. So I've got about a 1 in 7 chance. It's the same if a number is divisible by 7. It's like 1 out of those 7 numbers in a row. So it's like that. So what's the chance that this number is divisible by 7? Normally I'd say 1 in 7, but what's so beautiful about this trick is that you can actually do the division, and amazingly, it comes out evenly. The answer, when you do the division of 291,291 divided by 7, you get 41,613. So that's cool. But what's really neat is we can keep going and say, what's the chance that this number is divisible by 11? Now, again, should be a 1 in 11 chance. But what's crazy is that when we actually do the division, 41,613 divided by 11, it also comes out evenly. It is evenly divisible. No remainders, no leftovers. It's 3,783. And that's even more unlikely, that a number would be divisible by 7 and then also by 11 is actually greater than a chance, or it's a more outside chance. It's more unlikely than if I picked a card at random out of a deck of cards and got the one that you were thinking of. Which, when you're talking about magic tricks, no magician would go and try to do that. They would all have a trick or a reason to do it. And so being able to do something that's actually even harder than that, I just think is really cool. But we're not done yet. What do you think the chances are that this number, 3,783, is divisible by 13? Well, it should be a 1 in 13 chance. That's like the chance of you picking a card from a deck of cards and me knowing what number it is. I'm saying like, oh, you picked a queen or something like that. In fact, it does also come out even. When you do the division, you get 291, exactly the number that we started with in the first place. Do all the divisions always come out evenly? Does that trick work because I picked 291 and there's something special about that? Or could you pick any 3-digit number, write it twice in a row to get a 6-digit number, and then divide it evenly by 7, by 11, by 13? would it always come out evenly? Would you always get back to the number you started with? It's a very interesting question, very fun question, fun little problem, but it's a classic. And I like it for two reasons. And what I'm going to show you in just a minute is my magic trick that's similar in feel, but actually goes into some even stranger territory. And there's two reasons I like this. One is that the numbers you're dividing by are not nice numbers. 7, 11, 13. Maybe you follow the Twitter account of Howie Hua. If you do, you maybe have seen this meme where he has all the numbers from 2 to 10, and he says to them all, thank you for having such easy divisibility rules, but to 7, not you. 7 is not easy, and 13 is not easy. 11 has one that's not too bad, but I just love that you pick the numbers with hard divisibility rules or no divisibility rules, and you can still make this trick work. That's one thing I like. The other thing is I'm the inventor, co-inventor of the board game Prime Climb, and that's all about coloring prime numbers to see how multiplication division happens. And it's a beautiful thing that you can understand multiplication division as combining colors or removing colors. The problem is that it's really easiest to see when the numbers are small, and the whole problem of it is that when the numbers get too big, it gets very hard to tell what their factors are. It's just a tough problem. It's actually so tough that there's a lot of cryptography that's based on exactly how tough that is. So here's the trick I would like to do live and I haven't been able to do. And you're going to have to trust me that if you were seeing me do this live, I would take numbers that I hadn't picked ahead of time and I wasn't doing any tricks. But you can also follow along and I'll tell you how it would work for yourself afterwards. So I'm going to pick a 2-digit number and a 3-digit number. And I encourage you to do the same. So pick a 2-digit number and a 3-digit number. My 2-digit number will be 59. My 3-digit number, I'm trying to make them just weird, 828. Nothing special about either of those numbers. Seems okay. 59, 828. Now, similarly to how the last part went, we're going to take each of these and we're just going to write them in a row, repeat them until we get to 6-digit numbers. So my numbers will be 595,959, that's 59, 59, 59, and 828,828, that's 828, 828. You can do this with your 2-digit number and 3-digit number also. We're set to go. And now we've got two large 6-digit numbers, and we're going to go even larger. We're going to multiply them together. Multiply them together, and you get this monstrosity, 493,947,506,052. Now, the thing about divisibility rules is, you could look at this and say, well, I know it's divisible by 2 because it ends in a 2, and maybe you can get a little bit, but it's very hard to say what this is divisible by. But I'm going to say 3 numbers right now, and you can write these down also if you want to. 143, 259, 273. Just by looking at this number, and I have a kind of, it's hard to explain how this works, but it's just, there's a kind of sense I get about things where when there's this mid-range, when like I'm looking at 12-digit numbers, I sometimes just can tell the feel of these numbers that are going to divide them. And I claim that these 3 numbers will divide this large one. I know it would be much more impressive if I was doing this and it wasn't pre-recorded and I wasn't controlling the images, but you can still take your number. You should have a 12-digit number if you took your 2-digit number and your 3-digit number, extended it out to 6 digits, multiplied them together. Maybe you've got one. I'll show you how this works for you also. But let's see. Is 493,947,506,052, is it divisible evenly by 143? Very unlikely, right? Hugely unlikely. That's like, what's that like? That's like saying like, pick a random person and you say your birthday is either today or tomorrow, or maybe like in the first half of the day after that. And they're like, yeah, that's right. That's kind of the chances of that we're talking about. And yet, when you do the division, you can check me, it comes out. You get 3,454,178,364. Kind of incredible. But we're not done. Let's see if this number is divisible evenly with no remainders by 259. It's a 1 in 259 chance that it would be, right? It seems like there's no reason it should be. Hugely unlikely, and yet, when we do it, we get 13,336,596 no remainders. No decimal, no fraction, no leftover. It comes out perfectly. Do you think that 273 will divide into this one also? No reason why it shouldn't, right? But try it, and we get 48,852. Three-digit numbers that go into it. And now, at this point, what's weird is I'm really good with 12-digit numbers of saying, like, I can just see what works, but it's actually harder for me with these numbers. I think you can divide it by 2 and by other things and see how this factors. And actually, if you want to try to figure out how this trick works, figuring out how this number factors might give you a clue to figure it out. But I promised you that you would be able to get some flavor of this trick also. And you did take your 2-digit number, your 3-digit number, extend it into 6 digits, multiply them together. You have that there. Here's what I'm going to claim is that if you divide that number that you made by 143, it will come out evenly. If you take that quotient and divide it by 259, it will also come out evenly. And if you divide that final number that you got from that by 273, so again, those numbers, because I think I may have said one wrong, 143, 259, 273, do those divisions and it will come out evenly each time. The chance of that working is, I want to say, more than 1 in a million, and yet it works. That is the trick I wanted to share with you today. I encourage you to try it out, see if you can figure out why it works, how it works, if it works, and maybe you can even come up with your own version, your own variation. I hope you enjoyed it. Again, I'm Dan Finkel of mathforlove.com, and have a fantastic time with the rest of the buffet.